During database application design sessions, we have some of the concept that we use to make sure that your database application is scalable enough. So today we're going to be discussing a concept that we really don't discuss it too much when you're building those application, just because, and I think it's well known out there. But the concept is not clear, or who should use it and where should you use it. I think some of the developers be able to use it, but I just wanted to share a concept out there, the message I think we can be able to learn in all of us during product management. We want to look in the concept where database sharing is a technique used in database management to horizontally partition database across multiple service nodes, especially using Hadoop and big data, and also AWS as services. So you can use sharing in some of the AWS services that we have, especially the Amazon RDS and the relational database services. So you can deploy a shared database architecture using Amazon RDS for popular relational database like MySQL, Postgres, SQL, or SQL Server. So you would typically set up a multiple database instance, each representing a shard, and manage data distribution, replication, and failover across instances. So another services we can use is Amazon DynamoDB. DynamoDB is fully managed and NoSQL database services provided by AWS. It inherently supports automatic sharing and replication of data across multiple partitioning to ensure scalability and availability. You can define partitioning keys to distribute data even across shards. And also we have another database instance. We have Amazon Redshift. Amazon Redshift is a fully managed data warehouse service that supports sharing through distribution key. So by choosing appropriate distribution keys such as key even all, or you can share data across nodes to optimize queries, performance, and also and concurrency. We can also take advantage of Amazon Elastic Cache. If you're using cache layer in your architecture, you can share your database across multiple nodes. Amazon Elastic, which is an Amazon AWS managed in-memory caching services. So Elastic Cache support sharing for the both Redis and MEM engine. We do have another service we can do sharing. It's called Amazon Aurora. Aurora is a MySQL and PostSQL compatible relational database engine provided by AWS. It supports sharing through its multiple master and multiple region capabilities, allowing you to distribute data across multiple instances and region to improve scalability and fault tolerance. Also, we do have Amazon Document DB, which is a Mongo compatible DB. Document DB is fully managed MongoDB compatible. MongoDB supports sharing natively among documents. Amazon Documents simplifies the management of shared MongoDB cluster by handling a task like provisioning, scaling, and replica. So when you're using sharing in AWS, it's essential to consider factors like database distribution, replication, backup, and monitoring and maintenance to ensure the scalability, performance, and availability of your database system. Those are some of the Amazon services that we can use for sharing, especially the SQL databases and NoSQL databases. And also we can also use sharing in distributed services like Hadoop database in HDFS or distributed services. So in Hadoop, sharing is often referred to as data partitioning or data shuffling. It's a crucial aspect of Hadoop distribution computing framework, especially in context of Hadoop distributed services, the HDFS and MapReduce. So sharing in HDFS, Hadoop distributed file system, HDFS, stores large files and breaking them into small blocks, typically 128 megabyte or 256 MB each, and distributing these blocks across multiple nodes in Hadoop clusters. This is processed essentially for sharing when data is partitioned across different nodes based on block and boundaries. So you do have also MapReduce ecosystem, Hadoop ecosystem. So in MapReduce jobs, sharing refers to the process of partitioning input data in small chunk, each which processed by map task. Hadoop automatically handles this partitioning based on the input data formats and the configured input splits. Each mapper processes a shard or the input data independently, allowing for parallel processing across multiple node and cluster. So we do have also data processing during a MapReduce phase. Uh, During the map phase of a MapReduce job, input data is partitioned into key pairs, and each key is assigned to a mapper based on its key. Hadoop partitioning logic ensure that key value pair, which same keys are processed by same user, enabling aggregation of analysis of each data. So overall sharding in Hadoop fundamental role is enable distribution storage and processing of large data sets across clusters of commodity hardware. It allows Hadoop to efficiently scale out horizontally, handling massive volumes of data and computation in parallel across multiple nodes, thereby providing high throughput and fault tolerance for data intensive applications. So we have seen, in shared database architecture, data is divided in small subset called shards. So in each shard, contain a portion of overall data set, and each shard is stored on a separate server or node, depending on which which technology you're using. You're using cloud solution or using Hadoop ecosystem. Node in the database cluster. So this description allows the parallel processing of query and transaction, which can significantly improve system throughput and response time. So we do have sharing technique that we use out there, and some of these things you can just share with you. You can do more of research, but just to highlight, we have a key based sharing. As you can see here, is data partitioning based on the specific attribute of a key. For example, in a user database, user might be partitioned based on the user ID or geographical location. We have range-based sharding. Data is partitioned based on range values. For example, in database containing sales transactions, and data might be partitioned based on the date range and also of the transaction. We also have hash-based sharding. Data is partitioned based on result of applying hash functions in specific attributes of key. This eventually distribute across shards, but make range query is more challenging. So we will not be go on in depth discussing what hash-based sharding is. The hash technology underneath the database and development. But just to throw the concept out there, what is in hash-based sharding. And also we do have directory-based sharding. In this approach, a directory is a or lookup service is used to map data to appropriate shard based on some criteria. This can be used for dynamic data distribution and rebalancing. So as you can see, sharing, it can introduce complexity in database management, particularly in terms of data distribution, querying, routing, and maintaining data consistency across shards. So you have to be careful because when implementing effective sharding can have database hardware volumes of data and high transaction, making it valuable technique for scaling application in modern distribution computing. So it's not as easy as we just go through a brush through technology itself. You have to do a little bit of research on it before even you implement this concept in your database. But what I'm trying to explain here is it's a very good concept, especially when you have a database that you want to scale, especially those distributed services. You want to have your application always available, for tolerance, application out there. So it's a very good concept to dig into as a database developers, and also get some of those good concept out there.